In this video, we're going to talk about parallelogram properties and how to use them to solve problems. So what kind of problems? We're going to talk about how to solve angles and side lengths and even diagonal lengths inside a parallelogram with the 5 parallelogram properties. So we'll go over what the properties are. First property, probably the easiest one, it says that opposite sides are parallel. So when we look at a parallelogram, we can show that they're parallel by these little arrows. These single arrows indicate that any side with a single arrow is going to be parallel to that side. These sides have double arrows because they're not parallel to the sides that the purple are, but they're parallel to each other. All right. The next one says that your opposite sides are congruent. So I can mark them. These sides are going to be equal, and these sides are going to be equal, which basically means if this side is 10, this side's going to be 10. If this side is 6, this other side over here is going to be 6. Okay, the next one says that opposite angles are congruent. So by opposite angles, we're talking these two angles that are across from each other and these two angles that are across from each other are going to be congruent. And congruent means equal. So for example, if this angle was 100, this angle is also 100, and that means that this angle would be 80, and then this angle would be 80. The next one says that consecutive angles are supplementary. Consecutive angles are angles that are next to each other. So these two angles, this angle and this angle, are consecutive. They're following right next to each other. So if we looked at our problem from last time, we said that this angle was 80 and this one was 100, which makes sense because supplementary means they add to 180 degrees, which follows because opposite angles are equal. So these ones have to be the same. And these ones have to be the same. So the thing you have to check are the angles that are next to each other. Do they add up to 180 degrees? They should. Okay. And last but not least, it says the diagonals bisect each other. That means if I'm drawing in a diagonal, so a diagonal connects a side that's not an angle that's not immediately connected to the side. So these are my diagonals right here. So when diagonals bisect each other, if this is the point in the middle, it means this side and this side are equal. And this side and this side are equal. They're not the same. All the sides are not, all the diagonals are not equal. Like these orange guys are not equal to the green ones. Okay? But we do know that when you have the diagonals that bisect each other, they cross in the middle. It makes each diagonal get cut in half. So, for example, if this side is 8, then this one would also be 8. And if this side was 15, then this side would also be 15. Okay. So, let's do a couple different examples. So, first example here says Pqrs is a parallelogram. I'm going to tell you that so that I know it's a parallelogram and I don't have to draw in my parallel lines just because it makes it a lot to draw in my picture and harder for me to solve what they're asking me for. Okay, so all I'm going to do here is it wants me to find angle measures, so I'm going to kind of zoom this in. So we know that opposite angles are equal, okay? Here's what else I know. This angle right here has to be the same as this angle right here. Well, this diagonal that I'm looking at right here, this pink guy, totally cuts my angle in half. So if this side right here is 43, then angle 1 is also 43. And since we know that opposite angles are equal, both of these are also going to be 43. Okay, now I know that these angles and these angles are going to be the same. I also know that this diagonal cut my angle in half, so that angle 52 is the same as 6, so this angle right here is 52. But because these angles are equal, this angle right here is 52, and this angle not 53, is also 52. So when I go ahead and figure this out, I can say that the measure of angle 1, 4, and 5 are all 43 degrees. And the measures of angles 2, 3, and 6 are all 52 degrees. All right, next. Here I have another parallelogram, and now this one, we're talking about just the diagonals. And so we learned that the diagonals bisect each other. So that these two pinkies, right here and right here, are equal, so I set them equal to each other. So I can say that 2x minus 6 is equal to 12. So I want to take this equation and I want to solve it for x. So I add 6 to both sides. I get 2x is equal to 18, and to get x on a side by itself, I have to divide both sides by 2. So here I get x is equal to 9. Okay. Now these two orange guys are also the same, so I write an equation, set them equal to each other. 5y is equal to 20. To get y on a side by itself, I divide both sides by 5 and get y is equal to 4. Here they're not asking me to solve for anything else. I just needed to find x and y. All right, now let's put it all together. Here I have a parallelogram, and we're going to find some sides and we're going to find some angles. So I'm going to find my sides first. Here they are actually giving me the outside right here, but remember, in a parallelogram, the opposite sides are equal, so it's the same concept as we did in the last one. So here I'm going to say 6y is equal to 12. To get, 6x is equal to 12. To get x on a side by itself, I divide both sides by 6, and I get x is equal to 2. Now I have to find all the angles. So here's what I know. Remember, these are bisected, so this angle is 82, and then opposite angles are equal. So these are all 82. And then over here, pick a different color here. Pick this color. So I know that this angle right here is 64, which means over here, this is 64, and this is 64. So angles 1, 4, and 5 are 82, and angles 2, 3, and 6 are 64. And then over here we solve for x, and we said that x is equal to 2. Let me know if you have any questions. Good luck.